Hi, Chemistry. Mrs. KJ here. We're going to go over Unit 7, Organic Chemistry. In this unit, we are going to compare and contrast the structure, properties, and uses of organic compounds, such as hydrocarbons, alcohols, sugars, fats, and proteins. So we're going to start with 7.01, which is why is carbon so special? Carbon is in group 4A, so get back out your periodic tables if you've put them for a little while. How many valence electrons does carbon have? So here's carbon. We know it has 6 what? Protons. We know the atomic mass is 12. So we take 12 minus the 6 protons, tells us we also have 6 neutrons. And when we start out, we know that it is a neutral atom. So the amount of protons also equals the amount of electrons. So it has 6 electrons. But of course, we care most about the valence electrons. And how many valence electrons are there? 4. So 4 valence electrons, but it wants a total of how many valence electrons for a full outer shell in order to be blank? So here's our Bohr diagram. And we have some empty spots. So how many total does it want? It's going to want a total of 8. And once it has a total of 8 and a full outer shell, it will be stable. Now, in order to do this, is carbon going to share or is it going to gain and lose electrons? All right, so let's see. We talked about this. Group 1 has 1, so it's going to lose 1. Group 2 has 2 valence electrons. It's going to lose 2. Group 3 has 3 valence electrons. It will lose 3. Group 5 has 5 valence electrons. So what will it do for a full outer shell? Gain 3 for a total of 8. Group 6 will do what? Gain 2 for a total of 8. Group 7 will do what? Gain 1 for a total of 8. And group 8, what's group 8 going to do? Not react, because it's already have a full outer shell. Remember, these are the noble gases. So group 4 is right in the middle. It's right in between. It's easier, gaining or losing, and neither is really easier, so it's going to do what? Share electrons. It's going to share electrons. Now, when it shares electrons, how many bonds can it make? It can make a total of 4, right? It can share with something over here, can share with one over here, can share with one down here, and it can share with one here. In this case, I have it all bonding to other carbons. So now, if I were to count, I would have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So my center carbon would now be stable because it now has a full outer shell. Carbon can make single bonds like we just did here, where it shares one electron with one other atom. It can also make double and triple bonds. So let's do a quick example of that. What about if I have carbon attached to a hydrogen and another carbon and another hydrogen? All right, so if we're going to make this molecule, we're going to start by putting all the electrons or just the valence electrons? Just the valence electrons. Those are the ones that are going to be shared or gained or lost. All right. So hydrogen is in group 1. So how many valence electrons does hydrogen have? Just the one. And remember, hydrogen's so tiny, it's only going to make that one bond. So my hydrogens now are happy. My hydrogens are happy because they're so tiny, they only need 2 valence electrons for a full outer shell. Is my carbon happy? No. My carbon is not happy. You can see here it has 1, 2, 3, 4, 5 valence electrons. So what is it going to need to do? It's going to need to keep sharing and make another bond. Okay, so now how many valence electrons does each carbon have? 1, 2, 3, 4, 5, 6. Are they happy? Nope. So it's going to make another bond. It's going to make another bond. And now between the two carbons, we have a double bond. Two bonds between the same atoms is a double bond. Are my carbons happy? 1, 2, 3, 4, 5, 6, 7. Nope, we need a total of 8. So in this case, we're going to have to make what kind of bond between them? A triple bond. So now each carbon has 1, 2, 3, 4, 5, 6, 7, 8. And this carbon right here has 1, 2, 3, 4, 5, 6, 7, 8 total electrons that it has access to. And of course, carbon can bond with many other elements. And that's part of what makes carbon special, is that it can bond with a lot of other elements. Now, carbon can form long chains, chains with branches, and rings. All right, so up until this point, everything should have been a review. Okay, now if you're like, oh boy, I really forgot a lot of that, and you weren't taking notes, I would say stop right now, start at the beginning recording again, and take notes on anything that you're like, oh yeah, I forgot about that, or oh wow, I guess I didn't get that the first time, but I got it now. And if there's anything you have questions on, of course, come ask me. All right, so here's where we're getting into the newest parts. So carbon, we can form a straight line. We have carbon, 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 carbon with lots of hydrogens around it. It can branch. So I have my straight line, but now one of these carbons is coming off at an angle. And you can see instead of the carbon having only 2 carbons and 2 hydrogens around it, now this carbon is connected to 1, 2, 3 other carbons and a hydrogen. So we made a branch. Or they can actually become rings. Look at this. I have my carbons all together and they form a ring. Now in this case, yeah, it's a pentagon, but we call it a ring. Whether it's a square, triangle, pentagon, hexagon, heptagon, octagon, whatever, we call it a ring. And there's going to be less hydrogens around, which you might have noticed, because now some of these carbons are filling up those spaces by bonding to the other carbons. So carbon is needed for living creatures, plastic, fuel, and more. So entire jobs revolve just around carbon. Yeah, you can have an entire job where all you focus on is one little aspect of how carbons attach to each other, how they react, what they're going to create. It's really amazing. Now, we have the term organic. And you might feel like, whoa, you just totally skipped around, Mrs. KJ. I'm going to come back to it. So organic, we always think of no chemicals is used on food. All right. But in chemistry, you're like, oh yeah, just like a lot of other words, right? We have a more specific definition. The chemistry definition of the word organic is any substance made of carbon. So if you only work with carbon as your job, whether it's diamonds or coal, food, fuel, making things like the plastics, okay, anything with carbon is called organic chemistry. If you take chemistry like as a major in college, you will do an entire year of nothing but organic chemistry. All right, and of course, you've also heard of carbon with the carbon cycle, right? You guys talked about this a lot in biology class, about carbon dissolving in oceans, in sediments. We got our fossil fuel emissions that are adding more CO2 to the atmosphere, volcanoes, vegetation is going to take in some carbon dioxide, give out some oxygen, all this type of stuff. So we're not going to be focusing on this part, but I just kind of bring it in because a lot of what we're doing in this unit is going to relate back to biology. And so even if you feel like it's a review, I want you to really think of it like, oh, this is the chemistry side of biology and more of how it works. So we already had our first big new vocabulary word, which was organic. So if you didn't write it down, make sure you write it down. Organic equals any substance that is made of carbon. And now we're getting into our next ones. So our next vocabulary word is monomer. Mono meaning how many? 1. So a monomer is the repeating unit of smaller molecules, usually having carbon and hydrogen. So go ahead and hit pause and write that down. Our next vocab word is a polymer. Poly meaning how many? Many. It's a large molecule made of repeating small molecules. So the repeating small molecules are your monomers, joined in a continuous chain. Proteins, starches, and nucleic acids are naturally occurring examples of polymers found in organisms. Oil-based examples, plastic, nylon, Kevlar, yep, like the bulletproof vest stuff, styrofoam. So we really use carbon a lot in industry. We put together a bunch of monomers. We put together a bunch of repeating molecules, whether it's the same one over and over, or whether it's a pattern, and we keep repeating that over and over and over, chemically combine them to make a polymer. And then tons of examples. Tons of examples. So again, hit pause, add this to your notes. And we're going to talk about some specific type of polymers. We have biopolymers. What does bio mean? Life. So biopolymers are produced by living organisms. So we have starch, cellulose, protein, nucleic acids like DNA. Lactic acid from bacteria is polymerized into a bioplastic called polylactic acid. Plants are genetically engineered to produce bioplastics. How cool is that? We can use a plant to make a form of plastic, which can be harvested later and also recycled a lot easier. The field of synthetic biopolymers is relatively new, but efforts in this area of research may produce products such as CDs and DVDs made out of starch. Starch, like cornstarch. If you bake, it's really smooth and slippery. How weird is it to think that your movies, you can now buy them in DVD form or Blu-ray, and they're made of corn? Biopolymers are made from renewable resources, so they decrease the use of oil, and they easily degrade and thus reduce landfill use. So really cool. All right. We also, just as a reminder with recycling, okay, so most polymers are oil-based plastics, which are chemically inert. Inert means does not react, and they're not going to break down. So you throw them away, you know this. They just sit in landfills for hundreds of years. So obviously make sure you're recycling. Make sure you contact your local recycling place and see what type of plastic they recycle. And these are the obvious ones. But of course, like your plastic bags, you can make a bag full of plastic bags and take them to Cub or Kohl's or Hy-Vee or Target or wherever, and they'll recycle those plastic bags. So very important with these plastics. We need to be able to use plastics in so many things in our current life. And of course, recycling is the smart way to go. All right. The next thing that we're going to talk about with polymers are carbon nanotubes. Now, this is going to be a separate link. I want you to watch this. This is really amazing, and I didn't want to try and voice over it because it's actually really well done. So after you're done with this recording, you're going to watch the next recording and then fill out your worksheet, do the answer key. If you get them all right, great, take the test. If you don't get them all right, but you understand them after you go over them, remember, try the blank worksheet again so that you make sure that you know all the answers. And if you need help, of course, come talk to me. So next step, watch this next link, which again, you can't click it here. You have to click to the next link in the lessons. All right, talk to you soon.